In the previous video, I discussed cases 1 and 2 of the integration of powers of sine and cosine. So in this video, I'm going to discuss cases 3 and 4. So case 3 is when you have the integral of sine of u raised to n du, or you have the integral of cosine of u raised to n du, where n is an even integer. For cases 1 and 2, the powers of sine and cosine are odd. No? So for case 3, the power is even, or n is an even integer. So the method used in cases 1 and 2 does not work for this case. Instead, we will use the following identities from trigonometry. We have this one: cosine squared x is equal to 1 plus cosine 2x over 2, and the other one is sine squared x is equal to 1 minus cosine 2x over 2. So, let's review first. Okay. In trigonometry, first you have the sum and difference of two angles. So, for the sum of the cosine of the sum of two angles A and B, the identity is cosine A cosine B minus sine A sine B. Okay, you have learned this one sa trigonometry. So, if A and B are equal, let us say A is equal to theta and B equal to theta. So, sa right side, ma-change had ang A and B. So, if you have cosine theta plus theta, A becomes theta, B becomes theta. Same with sine A, sine B. Like this one. So, if you will add this one, that's 2 theta. So, cosine 2 theta, cosine theta, that's cosine squared. And then sine theta, that's sine squared. Now, so, this is the first identity for cosine of 2 theta. It is equal to cosine squared theta minus sine squared theta. But we have this basic identity sa trigo that cosine squared theta is equal to 1 minus sine squared theta. And also sine squared theta is equal to 1 minus cosine squared theta. So if we are going to substitute these identities for on this identity, this is what will happen. So cosine to theta, cosine squared theta will be replaced by this one. Okay? So sine squared theta times 2 na. No? So, okay. So cosine to theta will be equal to 1 minus 2 sine squared theta. So if you will solve for sine squared theta, it transpose the left side, and cosine theta 2 theta transpose to the right side. And you have this one. Cosine squared theta is 1 minus cosine 2 theta over 2. Now, the second one is sine squared theta to be replaced by 1 minus cosine squared theta. 1 minus cosine squared theta. So, ang cosine squared theta, ma-positive, negative times negative and positive. So, this is what will happen. Okay. So to solve for cosine squared theta, transpose 1 to the left and then divide it by 2 and you have this. Cosine squared theta is equal to 1 plus cosine 2 theta over 2. So we will be using these identities for cases 3 and 4, wherein is an even integer, because our objective here is to reduce the power of n. Okay. Uh, to increase the power of sine or cosine. Uh, Simple illustration. Find the integral of cosine squared x dx. So let us use this identity. replace cosine squared x by this one, and then separate, and you'll have this 1 half dx integral of 1 half cosine 2x dx. So this is very basic, and also this is also a basic but integral. Just let u equal to 2x, du equal to 2 dx. So by changing the variable, we have this 1 half integral of dx plus 1 half 2x is u cosine u, while dx is du over 2. Okay? And so 1 half times 1 half, 1/4 na. So you have 1 half x plus 1/4. Integral of cosine u is sine u plus c. So final step is replace u by its expression 2x, and we have this. Ah, pinaka-basic. Since ang power sa cosine is 2, the smallest even number. Okay. Now, what if you have this? Evaluate the integral of sine x raised to 6 dx. Okay, so the idea here is, since even siya, use the law of exponent. Convert this one na nasa power of 2 like this one. So make sure that you'll be able to reduce this one to either sine squared x or cosine squared x, so that we can make use of the identity. Now, this law of exponent na pag any base raised to two exponents, you just multiply. 2 times 3 and you have 6. And we're going to substitute the expression of sine squared x like this one. Alright? So 1 minus cosine 2x over 2 raised to the power of 3. So expand, no? Okay. You have 1 half cube is 1 over 8, and 1 minus cosine 2x cube. Raised to the, 1 minus cosine 2x raised to the power of 3 dx. So the next thing is to expand this one. Expand this binomial. You can use binomial theorem or binomial expansion, or you can multiply this one. You can perform manual multiplication. Okay. So to summarize, this is the result. This is the expansion of 1 minus cosine 2x raised to the power of 3. So it's 1 minus 3 cosine 2x plus 3 cosine squared 2x minus cosine 2x raised to the power of 3. And then separate all the terms, and you will have this 1 over 8 integral of dx minus this. Okay, and let u equal to 2x here. Oh, okay. Yeah. So let u equal to 2x, you have du 2 dx. For this one, use the identity, cosine squared. The exponent is even, so use the identity. But you have 2x. So using double angle na formula, this is the identity. 4 na ne. Because the original identity is cosine squared x, 1 plus cosine 2x. So since na-multiply siya by 2, na-multiply siya by 2, 4x. Okay? And then for this one, this is case 1. Case 1, since the exponent is odd, so the technique here is you extract 1 and then separate the remaining power of cosine, like this one. Integral of dx is x minus 3 over 8 cosine u. Dx is du over 2. plus 3 over 8, and then you have this identity dx. Oh, then separate this one. So squared na lang. So this will be part of du. So therefore, your u must be sine 2x. So that when you differentiate u sine 2x, you will have cosine 2x. So to have sine 2x, you replace this 1 by its identity. 1 minus sine squared 2x. Okay, let's simplify. Uh, 1 over 8x minus 3 over 8. 3 over 8 times 1 half, 3 over 16. Integral of cosine u is sine u. And then distribute 3 over 8 times 1 half, 3 over 16. Integral of 1 times dx with dx plus 3 over 16 integral of cosine 4x dx. And then cosine squared 2x is replaced by 1 minus sine squared 2x. Okay, so next, let u cosine 4x du for dx. Here, you have u sine, okay lang. Sige. Let's separate first. So, ang u ani is 2x, di ba? Or u is 2x, so we had this one, sine 2x, and then 3 over 16 integral of dx, x lang, and then 3 over 16 cosine u dx is du over 4, minus 1 over 8 integral of cosine 2x dx, and then plus na, negative times negative, so plus 1 over 8. Uh, so next is u na sana 2x and then du to dx, while this one u is sine 2x, du is cosine 2x times derivative sa 2x, it's 2 dx. So therefore cosine 2x dx is equal to du over 2. Okay. The next step is this. Okay. Recall na to. Okay. So, integrate. 1 over 8x plus 3 over 16x is equal to 5 over 16x minus 3 over 16 sine 2x, and then 3 over 64 integral of cosine u sine u minus 1 over 8, that's cosine u dx du over 2, and then 1 over 8 sine squared 2x is u squared, while cosine 2x dx is du over 2. Yeah. So next na step, u is replaced by 4x, and then 1 over 8 times 1 half 1 over 16 integral of cosine u sine u, pero ang u na to is 2x, so you have this one 2x, and then 1 over 8 times 1 half 1 over 16 u squared du. Power rule, you have u cubed over 3. Our u for this term is sine 2x. The next step is this. Final answer, 5 over 16x minus, ah, okay. Minus 3 over 16 sine 2x minus 1 over 16 sine 2x can be combined. It's negative 4 over 16 or 1/4. Negative 1/4 sine 2x plus 3 over 64 sine 4x plus 1 over 16 times 1/3 is 1 over 48, and then u cube, that's sine 2x raised to the power of 3 plus c. Uh, so for even exponent, the technique is to use the identity cosine squared x or sine squared x. And the objective is, or the purpose is, para ma-reduce ang power to 1. like this one. And para mo fit sa basic na integral. So, case 4 is similar to case 3, but in this case, you you now have two functions, sine and cosine. While sa case 3, you have only one, either sine or cosine. But the nature of the exponents are the same. Dapat m and n should be even. Both ha? Both even. If one of them is odd, then that will fall under case 2. Okay? Or where one exponent is odd. So for case 4, both exponents must be even. Okay. So the solution of this case is similar to the method used in case 3. So again, we will use the identities cosine squared x and sine squared x. So simple illustration. Integral of sine squared x times cosine squared x dx. To just replace this one by the identities, you have this. Okay, identities. Huh? Okay. So next is to extract 1/2 and 1/2. You write it before the integral. And then multiply 1 minus cosine 2x times 1 plus 2x. The product is difference of, or will result to difference of two squares. So you have 1 minus cosine squared 2x. If you will separate 1/4 integral of dx, okay. Again, this can be reduced using the identity. So cosine squared, but since you have 2x, so this will become 4 na lang. Like sa case 3 na illustration. So you will use this identity. Okay, so 1/4 integral of dx, and then you have this, and then separate this one. So 1/4 integral of dx minus 1 over 8. Yeah, this one. So basic na yan. So let u equal to 4x du for dx, and then integrate. And finally, you have this 1/4 x minus 1/8 x minus 1 over 8 times 1/4 1 over 32. Integral of cosine u is sine u. And then you replace u by 4x. Okay, so 1/4 minus 1 over 8 is equal to 1 over 8. Okay. Uh, but in case if you have like sine raised to 4 and cosine raised to 4, same lang. Make sure na ma-express nimo. You can express the integrand to this one, power of 2. And use property of law of exponent. Kato, a law of exponent like a single base raised to 2 exponents. Uh, you can use that the identity or the technique. Alternate solution is for this one. The alternate solution is you combine. Since they have the same exponent, you can write this one as this. The identity is double angle formula, but sine. Sine 2x is 2 sine x cosine x. So sine x cosine x is sine 2x over 2. So if you'll modify this one, ana lang. Sine x cosine x squared. Uh, this is still applying the law of exponent. So sine x cosine x will be replaced by this one, sine 2x over 2. Okay? And then 1/2 squared is 1/4. And then replace this one by the identity sine squared 2x. Pag sine is minus man. No? So, and then separate like this one. And then basic lang eh. Let u equal to 4x. Oh, okay. And you have this. Okay. So if you check natin sa previous na solution, this one. 1 over 8x minus 1 over 32 sine 4x plus c. While sa alternate solution, same lang. 1 over 8x minus 1 over 32 sine 4x plus c. So that's it for cases 3 and 4. So I hope that you have learned what the technique for cases 1 and 2 if the exponent is odd, and for cases 3 and 4 when the exponent is even. Okay. Thank you for watching.